Well, hello everyone. Today we will talk about the uniform circular motion and what is it due to. The uniform circular motion is the motion of the planets around the sun, the motion of the electrons around the nucleus, and the forces which causing it is centripetal and centrifugal force, and how those three equations of motion changes for a free fall. That means when the body is falling freely under the action of gravity alone, and when the object is thrown up against the direction of the gravity with some non-zero initial velocity. Okay, so let's see them one by one. Thank you.
Okay, we will now talk about uniform circular motion. It's a very special kind of motion. Why special? Because this is the motion during which the speed of an object remains constant, but still it is an accelerated motion. Yes, I said accelerated motion. It is a uniform circular motion, but it is still an accelerated motion. How so? Well, let's go for it. So you can consider that you have tied a stone with a thread and you are whirling it. Okay, if you have tied a stone with a thread, you have the thread one end in your hand, and when you are revolving it that way, or when you are rotating it, and when you release it at certain point, then at that particular point, for example, you release it here, then it will go along the direction of the tangent at that particular point. If you do it here, then this tangent. If you do it here or at other point, then at those particular points the stone may move in the direction of the tangent. So the velocity at every point is along the direction of the tangent at that particular point. So circle is made up of infinite points here. So there is infinite change in direction. Infinite change in direction, that means infinite change in velocity. And if velocity changes, then the motion will be the accelerated motion. So though this is the motion with a constant speed, this motion is an accelerated motion. The acceleration which comes into picture here is directed towards the center, and this acceleration is known as the centripetal acceleration. What do we call it? Centripetal acceleration. By centripetal we means towards the center. The direction of the acceleration is towards the center. So motion of all the planets around the sun is in elliptical orbit is one of the example of this kind of motion. Elliptical is almost like this shape which I have drawn around this acceleration. It is not a circle, it is like egg shape. Okay, it's almost egg shape. So those motions are the uniform circular motion, because all the planets have speed constant but direction changes at every instant during their motion. For example, if we talk about our Earth takes 365.25 days to complete a year around the Sun. 0.25 into 4 becomes 4, and that is, sorry, becomes 1, and we have a leap year at the interval of every 4 years, right? So this kind of motion in which speed remains constant but direction changes at every point, and every point the direction of the motion is along the direction of the tangent. Okay, so that's your uniform circular motion. So in uniform circular motion, if when the object is here, then you can see I have shown a force towards the center which is responsible for holding all these planets also in its orbit, and the force which holds the planet in their circular orbit towards the sun is known as the centripetal force. Which force is it? It is the centripetal force. So that centripetal force is holding all those mightiest of the planet in those orbits, right? So that force is providing you necessary gravitational force, because if there is no gravitational force between the planets and the sun, then the planet may move along the direction of the tangent, and they ultimately will keep on receding away. Receding away, that means they will keep on going away from the sun, and ultimately they will lose their path, the circular or elliptical path. Okay, so the centripetal force, that is the force towards the center, the force towards. At the same time, there is another force acting on the object that is the centrifugal force. So centrifugal force is always equal in magnitude to the centripetal force, and it doesn't have its own identity. It doesn't exist on its own. It exists only when centripetal force is present. Learn it here about centripetal and centrifugal force. So centripetal force, we have denoted it by FCP here. This is the force acting towards the center, and that's the real force. It actually exists, and it depends on the mass of the planet, the speed with which it is rotating in elliptical or circular orbit, and the radius of the path it is making around the sun. So that's why you have this equation of the centripetal force, that is F is equal to mv square by r, right? Now, F centripetal, here we have considered an object. At the center you can understand your sun. So sun, let's take our earth only. So here is our green earth. So on earth there are two forces acting. One is centripetal, another one is the centrifugal. So centripetal force is responsible for holding the holding the earth around the sun. The moment centripetal force raises its hand, sorry dude, no gravity from today. If there is no gravity, there will not be any centripetal force, and we will move out of this path at this point and will start going away along the direction of the tangent. And if there is no sun, there won't be any sustainability of life. There are no chances of survival of life, right? So this force, the gravitational force that we'll study later on, which is the weakest force in nature, though it is the weakest force, it is responsible for holding the mightiest of the object around the sun, and it has made our life possible. Got it? So that is because of the centripetal force. Now Newton's third law states that forces always occur in pair. The two forces occurring are always equal in magnitude and opposite in direction. ठीक है? So forces always are in pairs. Singular force never exists. Simple. There cannot be a single force. There is always another force contradicting to that. So here also we have a centripetal force towards the center. Then at the same instant we might have centrifugal force as well, and it is here shown with the negative sign. That means centrifugal force is acting away from the center. Centrifugal force, here it is a non-real force. It is a fictitious force, right? It's not a real, it's pseudo, it's non-real, it's false, and it's dependent force. Why have I used the word dependent? Because it doesn't have its own identity. It doesn't exist on its own. It exists only when the centripetal force is present. So whenever centripetal force, there will be the centrifugal force equal in magnitude and opposite in direction. Is that clear? And what is the magnitude? Magnitude here is equal to mv square by r. Got it? So centrifugal force is existing only when centripetal force exists, and it acts away, and that is not the real force. Got it? Good. So if when you are driving your car along the curved path, and if you do not get, for example, here this is a curved road this way, okay, so we have to take turn towards this side. On this side it's a deep valley, and if you drive at a certain speed, let's say on a curved road, they already generally mention that this is the maximum speed you should travel on this road to avoid the accidents, not accidents with the vehicle coming from the other end, but you may not sometimes get this necessary centripetal force also, which will keep you towards the center of that road. कि पूरा सर्कल जो रोड का हो सकता था, then on that road only you should stay, and you need to have that necessary centripetal force. You need to have that necessary gravitational force, and you will have it only when you drive it at certain speed. If you drive beyond a certain speed, because of inertia, you may move little straight and may ultimately fall into the valley, and the accidents may happen, right? So that's why they mention there. And the tires of the cars must also be good to have good gravitation, to have good centripetal force. Got it? Okay, then you could say that, sir, centripetal force does not depend upon that quality of the tire, it depends upon M, V and R. That's true, it depends only on those factors, but if the quality of the tire is bad, then also your car may skid and you may not be able to negotiate this circle and you will be thrown off the road, and centrifugal force may take you away from that road and you may fall into valley as well. Is that clear? So here we have learnt about two forces, centripetal and centrifugal force. Centrifugal is a non-real pseudo force. See, I'll give you one more example. For example, here is a train compartment and you are traveling in that, and you know there are the hangers are suspended there, you know, which we hold it with our hand because sometimes you don't get sit and you have to travel standing. So if the train starts going in this direction, so force is applied in this direction and the train is going. So force is in this direction, train is going in that direction, but this hanger, it is pushed pushed in the backward direction like this. It goes there. So force is here, but the hanger goes towards this side. So why has it gone to that side? Has any kind of force applied on that? No, but still it's going. So the force which comes into picture, which makes this hanger move in the opposite direction, is the centrifugal force. It is a pseudo pseudo, that's a non-real force. Is that clear? Good. So in uniform circular motion, speed remains constant, direction changes at every instant. Therefore, the motion is accelerated motion. The acceleration is known as the centripetal acceleration, always directed towards the center. At every point, the acceleration is towards the center, right? Good. The forces occurring are centripetal and centrifugal force. We are not violating Newton's third law that the forces are occurring in pairs. Okay, good. These three equations of motion, that is v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. These three equations takes different form according to the different kind of motion. For example, when the object is thrown upward with some initial non-zero velocity, because when you are throwing up, you obviously cannot have initial velocity 0. So that is some initial non-zero velocity. When you throw the object from this point to a certain height h, then at this point the final velocity v may become 0 because it will have to stop there and then ultimately it starts falling down, right? So v is equal to 0 at highest point and s is replaced by h, that is the height, which is also equal to your distance. So these three equations takes different form from different kind of motion. The first motion when the object is thrown up with some initial velocity. And in this case, while the object is going up, its speed is decreasing. If speed decreasing, that motion is a retarded motion. It's negative accelerated motion. It is negatively accelerated. So acceleration is replaced by minus g. G here is the acceleration due to gravity and it is still the acceleration. So if you write or replace a by g, it doesn't change anything, right? So the first equation becomes v is equal to u minus gt. A is replaced by minus g. At highest point, you can put this v is equal to 0 and you might have this equation u is equal to gt. Got it? Good. Then your next equation s is equal to ut plus half at square. Then again this a is replaced by minus g. This equation becomes ut minus half gt square, right? And the third equation v square minus u square is equal to 2as. At highest point you have kept v here is equal to 0. So you will have minus u square minus 2gh. A is equal to minus g and the equation becomes u square is equal to 2gh. So you can use this equation to derive to find out the maximum height achieved by the object, right? Now, these equations for the motion when the object is falling under the action of gravity alone. So when the object is released from a certain height, it is falling only under the action of gravity. There is no other force acting on it, right? And when you had this object in your hand, so your initial velocity is equal to 0. And acceleration is equal to plus g here, because while it is falling down, the speed increases. The speed of an object increases by 9.8 meter per second per second. So 9.8 meter per second by second becomes 9.8 meter per second square, and that is the value of g, 9.8 meter per second square. That is the acceleration due to gravity. Now, since the speed is increasing, the motion is speeding up and the acceleration is positive. That's why we are replacing a by positive g. And the v, after falling on the foot, it will definitely be 0, right? When it's fall on the floor, on the earth, it will be 0. But before that, the velocity, final velocity, was not equal to 0. And h is equal to s, that is the height. So s is replaced by the height of the object. First equation takes the form v is equal to 0 plus gt. You have kept initial velocity u here is equal to 0. Next equation, h is equal to ut plus half at square. You can replace this u by 0 here as well. So h is equal to half gt square. And last equation is v square minus u square is equal to 2gh. So u is 0. We have the equation v is equal to under root 2gh. So these are the three equations of motion when the object is thrown up with some initial non-zero velocity, or when the object is falling down under the action of the gravitational force of the earth alone, or under the action of the gravity alone, right? Where this g we have used in this chapter before learning that chapter gravitation is known as the acceleration due to gravity, and it is acting towards the earth, then it is minus 9.8 meter per second square. Is that clear? Good. So the chapter theoretically ends here. We will now do plenty of numericals and we'll understand how these equations play their role and how do actually things happen, right? Good. Thank you. Keep revising, keep studying. Good. Bye bye.